All right, so hi everyone. Today we're going to have a look at how we're going to solve logarithmic equations. But before we get started, there are some important things that we need to note of, which are knowing what the log laws are. And that some of the log equations involve using only one of the log laws, while others may incorporate the use of two or more log laws. Let's have a look at each of the log laws down below. Law 1 states that the log of x to the base a plus the log of y to the base a is equal to the log of x times y to the base of a. If we have the same bases, right, then we can multiply the numbers in the brackets to get the log of the product of those two numbers with the same base a. Then moving on to log two, I mean law two. I mean moving on to law two, right? The second logarithm law states that if we subtract the logarithm of one number by the logarithm of another number, then with the same base, that means that we can divide both of those two numbers up with the same base of log a in this case. So in this case, we have the logarithm of x to the base a minus the log of y to the base a equals to the log of x divided by y with the same base a. All right, oops, I forgot to add this power in. So there we go. All right, let's have a look at log law number 3 now. Log law number 3 states that the logarithm of a number with the power on top with a certain base and equals to the power times the logarithm of that same number and that same base. For instance, we have the logarithm of x to the power of n to the base a equals to the power n times log x to the base a. So hopefully this should make sense. So moving on to log 4, and we have the log of 1 to the base a equals 0. In its more general form, we can say that the fourth logarithm law states that the log of 1 to the base of any number will just equal to 0. And the fifth logarithm law states that the log of a number to the base of that same number, right, will just equal to 1. For instance, the log of a to the base a and will just equal to 1 and so forth. So that's those two are fairly simple, laws 4 and 5. And the last law that we need to deal with is law number 6. So law number 6 states that when we divide log to the 1 over x to the base a will just equal to negative log a to the negative log x to the base a. So that should make sense. If or let's have a look at log 6 a little bit more closely. Because I think that would make better sense then. Log law number 6. This is log a 1 over x equals negative log a x. So the reason why this is the case for law number 6, right, is that if we do log a 1 over x, right, that would equal to log a x to the power of negative 1. Oops, made the one a bit too big, so there we go, that's better. And then using logarithm law number 3, right? So let's move this power -1 over onto this side. So we have -1 times log a to the x then, right? And therefore it will just be negative log a to the x. So hopefully this should make a little bit more sense now. So therefore logarithm 1 over x to the base a will just equal to the negative log x to the base a then. So this should make sense now. So let's dive into the questions. So let's have a look at question 1. So question 1 should be fairly simple because we're only going to be using one of the log laws. So we have log 4 to the base 2 plus log 8 to the base 2, right? So since we're adding those two logarithms up, then that means that we're going to with the same basis, then that means that we're going to use log law number 1 then. So in this case it will be log base 2 4 times 8 in brackets, and then we get log 2 on log base 2 I should say, and then we have 32 in brackets. And then now we can evaluate this. Let's make things simpler. So let's convert this 32 into its base format, so into its index format. So what I mean by that is that this 32 on this side here is now going to be 2 to the power 5, since 2 to the power 5 equals 32 then. And then let's go back to our log laws, right? Which log law do we need to use? So now we need to use log laws 3 and 5. So to complete this. So it's because this 5 will just be on this side, and then we just have log 2 to the 2, and then so we're using log law 3, and finally we can use log law 5 to fully evaluate this, which is where if you remember from the previous slide, it's where the logarithm of a number to the base of that same number is just going to equal to 1. So let's go back. So it will just equal to 5 then. So hopefully this should make sense. So you don't have to use all the log laws. You can just use log law number 1, and then from log 32 to the base 2, you can just evaluate. You don't necessarily have to use this method. I'm just showing you this method since it makes it a bit easier to work through things. So but yeah, so let's move on now. So moving on to question 2, we have log 81 to the base 3 minus log 9 to the base of 3. So in this case, the second log law is in use. So we have logarithm base 3, and then in brackets we have 81 divided by 9. So log 81 over 9 to the base 3. And then we have logarithm 9 to the base 3. And then we're going to do this same method as what I've done for question 1. So that would mean that we have log 3 squared. Oops, this is a bit of a wonky 3. That's okay. Equals to log 3 to the base 3. And then solving from there, we just simply get 2 then. Alright, so next question, we'll have again, it's pretty much the same as question 2. It's in terms of the log laws that we're using, because we're subtracting 2 logarithms from the same base. So again, we're going to use log 2 for this one. So it'll be log with base 5, and then we have in brackets. So it'll be log 625 over 25 with base 5. Then so. And then we have log 25 with base 5. And well, I'm not going to show you the method in detail now, because I think you'll be able to understand how we get how to evaluate from here from this step onwards. So and then we just get 2 then. All right. Next one. So we have log 8 to the power of 2 with base 2. So what we remember from our previous slide, log, we move this power down onto this side, and then we multiply that power by the logarithm. So using the third log law, we get we have 2 times log 2, log base 2, or log 8 with base 2, and then we just have 2 times 3, and then we get 6. So it's fairly straightforward, pretty much. So it's not difficult. Next one. So with question 5, this involves more than one. We're going to use more than one log law, right? Because there's both a plus sign and a minus sign with the same base. So that means that we need to use 2 logarithmic laws, I should say. So we have so in other words, the best way to tackle this question is that we break this question down into 2 parts, right? So let's have a look at the first 2 logarithmic numbers. So we're going to add log 27 base 3 by log 9 with base 3. So we're going to do that first. So so we then have log 27 times 9 with base 3. Or actually, hang on, we'll just use the longer method for this one. And then we have log base 3 and then 243 minus log 81 with base 3. Then we have log 243 divided by 81 with base 3. And then we just get log 3 with base 3, and that's just going to equal to 1 then. Alright, so this shouldn't be too complicated though. All you have to do is break the question down into 2 parts, right? So so by that I mean working through with the first two logarithmic numbers, right? So I'm adding those two numbers up, and then once you've done that, from this step onwards, then we now subtract the two log numbers. So it's just easier to break it down into two steps, then rather than just confusing yourself and using the one step. So hope that helps. So moving on to the last two questions. So we're now gonna solve for x, right? So let's have a look at question 6. So question 6 we have log 1/9 with base 3 equals x. So the way we're going, so which law do we need to use for this one? Well, before we get into that, let's convert this 1/9 into its index format. So we have that equals to log through base 3s, and then that's going to be 1/3/2. Oh no, 1/3 to the power of 2 equals x. And then that's going to be log 3 to the power of -2 equals x. And then we now use the third log law to bring this -2 over to this side. So we have -2 log to 3 with base 3. And then we have x. And then therefore x is just going to be -2 then, since the logarithm of a number with the base of the same number is just going to equal to 1, which is on the first slide with for law number 5. So hopefully this should make sense. So yeah, let's move on to the last question. So for the last question we have log x to the base 4 plus log 64 to the base 4, and then subtract that by log 16 to the base 4 equals to 2. So let's do this one as well. So we have because we're dealing with more than one log law for this question again, right? We're going to break this question down into two parts. So we're going to add the first two terms together first. So we have log with base 4, and then brackets 64 times x, right? And then minus log base 4 16 equals 2. And now we can subtract the two logarithmic numbers. So since we've already added those two numbers up together, so now we can do that, subtracting. So log with base 4 and 64 times x over 16, and that's just going to equal to 2. And then we have log with base 4 and in brackets 4 times x, and that's just going to equal 2 and 2. And then now we have log 4 for x still on the left hand side. Equals Oh yeah, so let's ensure that we have the log 4 on both sides of the equation. So just so that we can make things simpler. So we have log 4 and 2 times log 4 to the 4, right? And then we bring this 2 up as a power. So that's going to be log base 4 and then in brackets 4 squared. So that's just going to be 16. And now since we have the log functions with the same bases on both sides, right, we can cancel out the logarithmic functions then. So we can cancel the log parts of it out. So and doing that, this just leaves us with 4x equals 16. And then therefore we get x equals 4. All right, so this one is a little bit tricky, but it shouldn't be too difficult once you get your head around it. So it's just using multiple log laws, right? So in summary, to make things easier, we add those two logarithmic numbers up together. And then we just get log 64x with base 4, and then subtract that by this log number here. So and then from there you can just simplify it to get log 4x with base 4, and that equals to 2. And then we can add the log 4 to the 4 to the base 4 on this side of the equation, so that's that way we can now cancel. Well, we can now cancel out one, and then but before we cancel things out, we need to bring this 2 over up here as a power then. So that would be log 4 squared with base 4 then. And then once we have this expression here, then we can cancel out the log base part of it, and then you're just left with log 4x equals 16. And yeah, so just remember, if you have also remember that if you have the log with the same bases on both sides of the equations, then you can cancel it out, as long as you don't have different numbers on both sides down there. So which is why we move this 2 up as a power of then. So hopefully this should all make sense now. So but yeah, so let's go back to the first slide. And just to recall, these are all the log laws I've spoken about earlier. So hopefully you should have a reasonably good grasp of those laws. So but yeah, so let's stop there. So yeah, so thanks guys for watching this video. Hope you even learned something out of it. And yeah, so I'll see you in another video. So let's take care, guys. Bye.